In our previous video, we adjusted the mesh of the components nearest to the location of the removed column in order to obtain accurate results. We also designated the column's elements below the girder level to be removed at the beginning of stage 2, while preserving the elements at the top of the column to keep the connection with the girders intact. In this video, we'll run the analysis and look at the simulation in the ELS viewer. We'll also examine some of the ELS output that we might need to assess this building for progressive collapse. We can adjust the displacement scale factor from the control bar at the bottom of the window to have a more pronounced visual of the building's deformation. ELS also allows the user a host of options to visualize the results of the analysis to obtain a precise idea of the behavior of the structure under the given loads. To start with, let's create a chart for the deflection of an element at the bottom of the connection with time. We'll select the element and create a new chart using the Visualization tab's New Chart command. We can see the vibrating pattern as the building settles after the column removal, and we can deduce that the maximum deformation was around 2.1 inches, around 0.2 seconds into the analysis. Let's look at the behavior of one of the reinforcement bars that have undergone yield stress. We can show those springs using the Show Springs dialog box. But we must activate reading the spring states from the Preferences window first. Due to the large number of springs in most problems, this option is disabled by default since it is demanding on system resources. So we recommend activating it only when spring states are being actively examined. We'll also hide the upper 3 levels. We can now head to the Show Springs dialog box, activate the States checkbox, choose the Yield state from the States Settings window, increase the size of the springs to view them clearly, and choose to show them on level 1 for all components. Now we can scroll to a frame where we can see some springs in yield and select one of them. Let's draw a stress-strain chart for the selected spring. We can see that the spring reaches yield stress at 60 ksi, as specified in the previous video, and reaches a maximum strain of around 0.007, where the vibration starts. Let's display the rotation contours to see where the maximum rotations occur. From the Visualization tab, we'll choose Contour Settings, Element Kinematics. Select Rotation around Y for all frames and calculate the limits for the whole problem. Now, we'll scroll to a frame with heavier rotation. We can select one of the critical elements and plot its rotation with a normal stress in the spring. From this chart, we can calculate the plastic rotation by subtracting the elastic rotation from the maximum rotation, then compare this value to the one calculated from code specifications. Since we don't need the spring states anymore, we can turn off the Read Spring States option to enhance performance. Now, let's show the straining actions from the Problem Features tab. We'll start by showing the shear forces. We'll select Shear 3, show the envelope and its text value. And now we can compare the shear force to the maximum at any given frame. We can also display the normal forces if we need to compare them to any code specifications for the columns. Instead of showing them for the whole problem like we've done in the last step, let's show them for the closest 2 columns to the removed column on level 1. We can select 2 elements from the columns, go into the Properties browser, scroll down to the Straining Actions section, show the normal type, as well as both the envelope and its text values. We can now scroll through the simulation and see the normal force diagram at each step in comparison with the envelope. This concludes this series on the analysis of buildings under progressive collapse. We hope this series has given you an idea about some of the many capabilities of ELS. Please do reach out and ask about how ELS can help you solve your specific simulation problems.